Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, the first thing you should do is to perform the nth term test. So with the nth term test, you're trying to find the limit of this thing here. You're trying to find the limit of this thing here as n heads towards infinity. In order for our series to converge, this limit here must equal 0. If it's anything other than 0, then it's going to diverge. But the thing is, in order for us to use the nth term test, we need to compute this value here. We need to find out the limit of this thing here as n heads towards infinity. But the problem is, it's hard to compute this limit because you've got n factorial versus 4 to the power of n. So I've actually done a video on n factorial versus, I don't know, 4 whatever factorial. I've done a video on this. You can actually tell which one will be bigger as n tends to infinity. There is a way of being able to tell. But let's just so if you truly understood this video, which I've done in the past, then you can actually compute this. You can actually tell if this is going to head towards 0 or if it's going to head towards infinity. You can actually tell. But let's just say, for the sake of argument, you can't compute this limit as n heads towards infinity. So you can't really perform. Let's just say, for the sake of argument, you can't perform this nth term test. So you've got to do something else. So we can't. Let's just pretend we can't do this. You probably can't, but let's just pretend we can't do this. So here because we can't perform this, we need a different test. Well, here you've got n factorial. Whenever you have n factorial, you should think about the ratio test. So let's perform the ratio test on this, because at the moment we can't. We don't know the limit of this as n heads towards infinity. So we've got to do something else. Well, because this thing here contains n factorial, we should think about the ratio test. So with the ratio test, you're always wanting to know this value here. You're always trying to compute this value here. The next term divided by the current term, and then take the absolute value of it. Well, this whole thing here will then give you this, which we've done in the past, and you should get from here to here. So the am plus 1 is this whole thing here, and then dividing is the same as you multiplying by the reciprocal of am, which is this thing here. Now tidy this thing up. So visualize this thing here as a block times another block, and then this thing here, remember, n plus 1 factorial is the same as n plus 1 plus 1, and then times n factorial. So rewrite this as this thing here, and then this thing here, rewrite this as a block of 3 to the power of n times 3 squared times this thing here, that's this thing here, and then visualize this as one block multiplying another block. So now tidy this up. This will cancel out with this. This will cancel out with this. This will cancel out with this. That will then give you this thing here, this thing here, this thing here, this thing here, and then what? Let me think. And then this thing here will cancel out with this. This thing here will cancel out with this. So that will give you 3 and a 4, 3 and a 4, and then that will take you to here, and then remember, n is moving from 1 to infinity. So this thing here will never be negative. So you can drop the absolute sign. That will then take us to here. So as n heads towards infinity, this thing here is just going to get bigger and bigger and bigger. This thing here is just going to get bigger and bigger and bigger. And then you times a constant, the whole thing will just get bigger and bigger and bigger. So the limit is actually infinity. So going back to here, going back to here from the ratio test, because this value here is bigger than 1, then we can conclude that this thing here heads towards, well, this thing here will diverge, because this thing here equals infinity. Well, infinity is bigger than 1, so we can conclude that this thing here will diverge.